Okay, so we are still in the middle of topic 4. This is day 9. And these are the story problem pattern part of the chapter. We've already learned how to solve 2 equations using substitution method and linear combination method. And you're going to need to be able to do that on these problems. But we're going to talk about how you can set the problems up based on what the scenario is. Okay, so first one, there's a basic process that you can follow for solving any kind of story problem. The first thing you want to do in the process is what we call label your unknowns. Your unknowns are what you want to find, and usually we call them X and Y, but you can call them any letters you want that keep them convenient. And you might want to write down the units, particularly if you have a problem that's mixing inches and feet or 2 different types of units. You're going to want to make sure that you specify those. Okay, so second thing you're going to do is if you have 2 unknowns, you need 2 equations to solve it. So you're looking for 2 relationships that you can set them equal to. And keywords that you want to look for are totals, the total amount. Keywords for an equal sign are is or will be, which we already studied at some point. Okay, number 3, you want to write the problem in words. So you're just trying to get the problem basically onto an equation. And then when you're done with the words, then you can fill in the X's and the Y's. It's usually easiest if you just do the words first. So at this point, you should have 2 equations that have X and Y in them both. And so your 4th step is always to solve those equations. And you can do substitution method, you can do linear combination method, or you can mix the 2. It's up to you what you decide to solve them with. And, you pick the easiest one. The last thing you want to do when solving any story problem is ask yourself, do the answers make sense? Are they logical? Or reasonable? And that will give you an indication of whether or not your equations actually worked. Okay, so Roman numeral 2. We're going to start with mixture problems. Now, on your homework, the mixture problems are 3, 8, 11, and then 13 through 16. Those are the mixture problems, and you can use the mixture problem pattern with those. So what is a mixture problem? A mixture problem is where you have 2 things mixed together, and you're trying to separate them and figure out how much of each there are. So 2 things mixed together, and you're trying to separate them. All right, for most mixture problems, the first equation is going to be what we call a counting equation. And that's usually something like X plus Y equals a total number when you add them together. That's your typical start. The second equation is typically your calculating equation, and this is where you're going to use money most commonly, but also things like pounds. So you're going to have something times X plus something times Y equals total dollars or total pounds. And that's the one that's a little more challenging to put together, but 90% of the mixture problems you're going to see in an Algebra 1 class are going to follow this pattern exactly. All right, we are going to do an example. Okay, it says a health food store mixes granola that costs them $4 per pound and raisins that cost them $2 a pound together to make 25 pounds of raisin granola. How many pounds of raisins should they include if they want the mixture to cost a total of $80? So obviously the granola is more expensive, so you don't want to use more granola than you have to keep the costs down. Okay, this is a mixture problem because you're trying to mix granola and raisins together and come up with a mixture at the end that has a certain cost. So that's how you know what type of problem it is. So what are we trying to find? We want to know pounds of raisins, and we're going to need to know pounds of granola. So I'm going to use R for the number of pounds of raisins, and I'm going to use G for the number of pounds of granola. Those are labeling our unknowns. We need to find pounds of raisins. We need to find pounds of granola. Okay, now we're going to read this and try to find two relationships. And we're going to look for words like sum or add and definitely totals. So it says, a health food store mixes granola that costs them $4 per pound and raisins that cost them $2 per pound to make 25 pounds of granola. So the total number of pounds of granola is 25. So that's our counting equation. So if you take R pounds of raisins plus G pounds of granola, however much they are, you want 25 pounds total. All right, that's our first equation. Counting equation. Okay, second equation. How many pounds of raisins should they include if they want the mixture to cost them a total, there's that word, total of $80? So in the end, they want it to be $80. So this is where you're going to calculate, and remember the pattern, it's usually an amount times X plus an amount times Y. Okay, so raisins are $2 per pound. So if I take $2 times the number of raisins, that'll give me how much the raisins cost. Plus, my granola is $4 per pound, so I'm going to take $4 times G pounds of granola, and money plus money should equal $80. All right, so now what we're going to do is pull these equations and take off the dollar signs and see what we have. We have R plus G equals 25, and we have 2R plus 4G equals 80. Put a box around it. Those are our two equations. Okay, so now we're going to solve. And you could use substitution method or linear combination. I think I'm going to do linear combination. I want to know how many raisins there are, how many pounds of raisins. So I want to eliminate the granola. So this one's a 4G. Okay, and that one's a G. So I need one to be a 4 and one to be a negative 4. So I'm going to take the top one and I'm going to multiply everything by negative 4. And that will give me negative 4R minus 4G equals negative 100. Now the second one already has a positive 4, so I'm just going to leave that one the same. So 2R plus 4G equals 80. And then linear combination, draw a line, add them up. 4 minus 4 means the G's go away. Negative 4 plus 2 is negative 2R equals negative 100 plus 80, which is negative 20. So then I'm going to multiply by 1 over negative 2 on both sides. A negative divided by a negative is a positive, and 20 divided by 2 is 10. So the question was, how many pounds of raisins should they include? So it's going to be 10 pounds of raisins. And that's your mixture problem. All right, so flip the page. We're going to do age problems. And these age problems are really easy to spot because they're going to include past age, present age, and or future age. So they're different than just straight up age problems, which we worked on earlier this year. Okay, so it's really easy to spot an age problem. Shirley is 21 years older than Laura. In 6 years, Shirley will be twice as old as Laura. How old are they now? You can tell this is a past, present, future because we're talking about in 6 years versus right now. So we want to know how old they both are. So let's make X Shirley's age. And we'll make Y Laura's age. Okay, so when you do a past, present, future problem, it's usually a good idea to make a chart. So we're going to give Shirley her own row and Laura her own row. And then in the chart, we're going to have past age, present age, future age. Now, you're not going to use all parts of the chart all the time, but any kind of past, present, future problem will fit on it. Okay, so everything in these problems is relative to their present age. So first thing you want to do is just fill your letters into the present age column. So X is Shirley's present age, or her age now. Y is Laura's age now. Now, when we read the problem, it talks about in 6 years, but it doesn't talk about the past. So we're not going to use the past column on this one. We're just going to use the present and the future. So let's read it again. Shirley is 21 years older than Laura. Okay, that's all stuff that's true now. In 6 years, Shirley will be twice as old as Laura. So our future expression is in 6 years. So X plus 6 is Shirley's age in 6 years because we add 6 to it. Laura's age in 6 years is Y plus 6. Okay, here's where we're going to take the problem and put it into words. Shirley is 21 years older than Laura. Okay, so this would be Shirley right now is 21 years older than Laura, which means we should be able to take Laura's age now and add 21 years to it, and that'll give us Shirley because she's 21 years older than Laura. In 6 years, so now we're talking future Shirley. In 6 years, Shirley will be, that's your equal sign, twice as old as Laura. So 2 times future Laura. So we've made the problem into words and a math expression with an equal sign. Now we're going to fill in present and future. So Shirley now is X. X equals Laura now, which is Y, plus 21. There's our first equation. Now we do the future. Future Shirley, that would be X plus 6 equals 2 times, okay, future Laura. Future Laura is Y plus 6. Be sure and put it in parentheses. And those are your 2 equations. All right, as always, you get to choose. You want to do linear combination or substitution. Since the X is already solved, I'm going to do substitution on this one. So I'm going to take that and I'm going to replace X with it. So that gives me Y plus 21 plus 6 equals 2 times Y plus 6. So all I did was do substitution. I substituted Y plus 21 in for the X. And now we simplify. 21 plus 6 is 27. So y plus 27 equals, distribute the 2, you get 2y plus 12. And then now we're going to solve for y. So subtract 2y over to the left. So negative y plus 27 equals 12. And we're going to subtract 27 over to the right. So negative y equals negative 15. Multiply both sides by a negative 1 to get rid of the negative off of the y. Negative times a negative is a positive, y equals 15. So we've got Laura's age. Laura's going to be 15 years old, but we need Shirley's age. So this is substitution. So take what you got, substitute it back into the first equation. We get x equals 15 plus 21, which is 36. So Shirley is 36 years old. And you always want to answer the question in terms of what's being asked. You always want to say what x and y are and use your good units. All right, that is how you do an age problem. You set up a past, present, future chart, write the equations using words, and then fill the values in from the chart, and then solve. All right, last problem pattern we're going to learn today. Oh, sorry, let me move this up. Last problem we're going to do is a rate comparison problem. Give you a second to catch up. I'll put that back up at the end if you still need to fill it in. Okay, so let's do Roman numeral 3. Rate comparison. Oh, by the way, past, present, future problems are 4, 5, and 6 on your homework. So you might want to write that down. Are we going to what? Oh, sorry, you're right. That should be 3. That should be 4. All right, rate comparison problems. These are problems 9, 10, and 12 on your homework. And yes, Roman numeral 4. Okay, here's a rate comparison problem. Computer Information Incorporated charges $10 per month plus $7 per minute for computer access to its information. Data Access Corporation charges $20 per month plus $5 per minute. For what number of minutes are the charges the same? So in a rate comparison, they're going to give you 2 separate rates, and you got to figure out when they're the same. Now, we've already done rate problems before. This is the same thing. We're just going to do 2 different rate problems and compare them with each other. Okay. So the old way that we put together rate comparison problems was you have a flat fee plus a calculated rate. This usually depends on minutes or seconds or pounds. So that's times X equals a total number of dollars. That's the old one that you guys did really well on first semester. So we're actually going to use the same pattern. The only difference is you're going to put company number 1 on the left equal to company number 2 on the right. And you're going to take out that total number. So for each company, you need a flat fee plus a calculated fee times X. And then for company 2, a different flat fee plus a calculated fee times X. Okay, in this one, the question is, for what number of minutes are the charges the same? So our X is the number of minutes to break even. And break even means the same thing as cost the same. Okay, so let's do Computer Inc. Computer Information Inc. It charges $10 per month. That's our flat rate. So we're going to go $10 plus $7 per minute. So $7 times X number of minutes. And depending on the number of minutes, that's how much it will cost. Equal to, okay, now data access. Data access charges $20 a month, which is more, but it only charges $5 per minute. So it's less of a fee per minute. So logically speaking, if you're only going to use a low number of minutes, you're going to want the $10 flat rate. If you're going to use a lot of minutes, you're going to want the $20 flat rate because the per minute charge is less. Nod your head if that makes sense. Lucky for you, you guys have phone packages, so some of this makes a lot more sense than it did when I was in high school. All right, so that's your equation. You set one rate equal to the other to check the break-even point. All right, so 10 plus 7x equals 20 plus 5x. We're just going to solve normally. So I'm going to subtract 5x over to the left. So I have 10 plus 2x equals 20. Then we're going to subtract the 10 over to the right. So 2x equals 10, and obviously 5 times 2 is 10. So x equals 5 minutes. So if you want to know when they break even, it's at 5 minutes. So the minute that you use more than 5 minutes, you're going to want to go with this company. If you're going to use less than 5 minutes, you're going to want to go with this company because it's a lower base charge. Okay, that is a rate comparison problem.